Okay, so when we left off here at the end of the first hour, we had just started talking about fractions, and we saw this little, how these tie in with what we did with our whole numbers. If we want to understand how the fractions work, the key is understanding what it means to have a name of a seventh or a fourth. And that comes back to that, probably the easiest way I know to illustrate it is that elementary school illustration of a pizza or a pie or whatever you want to call it. A name of a fourth means that pizza or whatever is cut into 4 equal pieces. Pretend those look equal. I am artistically challenged. Anyway, you think of it as every whole object is cut into 4 equal pieces, or it takes 4 of those pieces to make one whole object. The 3, the count, or the numerator, means that we have 3 of those pieces. I can't color any better than I can draw. So that's 3/4. Now we saw up here 1/4 plus 3/5. We couldn't combine those because they didn't have the same name. One of the first things we have to be able to do is to change the name of a fraction so that we can combine them. The easiest way to do that, in this illustration at least, is let's cut each slice into more equal pieces. I just randomly picked the number 3, so I'm going to cut each slice into 3 equal pieces. Now, how many pieces does it take to make one whole object? There's 12 of them. We had 4 before. We cut each into 3 equal pieces. 4 times 3 is 12. In yellow there, how many pieces do we have? 9. We had 3. We cut each into 3 equal pieces. 3 times 3 is 9. Do we have any more or less than we did before? No. 9/12 and 3/4 are exactly the same amount. They just look different. The reason we were able to keep them the same is this thing right here, the 3/3. That's telling us the denominator of 3 is telling us it takes 3 pieces to make a whole object. The numerator of 3 is telling us we have 3 of them. We have one whole object. That is equal to, I don't know where that came from. That is equal to 1. And when we multiply anything times 1, what happens to its value? It stays the same. This is what we refer to as a unity fraction. And it does have a value of 1 because the numerator and denominator are equal. We're going to use unity fractions a lot in math for measurement conversions, dosage conversions, stuff like that, because you can multiply by them and it doesn't change the value, it just changes the appearance. And most of manipulating things with math is about changing the appearance without altering the value. I'm not going to talk a lot more about like reducing fractions and stuff like that. We're going to assume you guys have that. We're going to do it as part of our examples as we go. So if you see me doing it as part of one of our steps and you don't understand it, please let me know and I'll stop and go over it then. But let's now take a look at trying to add that 1/4 plus 2/5. They have different names. We need to give them the same name. Well, the first thing we need to do is figure out what that same name, or the term is common denominator, is going to be. There are several ways of going about it. One way to find a common denominator is to just multiply the denominators. We take 4 times 5, which is 20. That will always give us a common denominator. It may not be what we refer to as the least common or lowest common denominator. A lot of us have been told we have to find that least common denominator. That's not true. Any common denominator will work. They might be a little bit more work, but they will give us the correct answer. But another method or possible way of finding it is to make lists. We got our 4 and our 5. We could count up. I'm going to do the 5s first because those are easier. We'd have 5, 10. What would be next? 15, 20, 25, and so on. For 4, it would be 4, 8, 12, 16, 20. There's our first match. That's our least common denominator. So in this case, both of those methods gave us the same one. There are other methods that are more complex, like factoring and stuff like that. They get to be kind of complex when we're working with just numbers. If this were an algebra course and we were dealing with algebraic numbers, that would be one way of doing it so you didn't make mistakes. If that's something you're interested in seeing other methods, let me know and I will go over them with you outside of class. For right now, we're going to move on to the next step. I tend to add and subtract vertically. It's the way my mind works. So I'm going to set this up vertically right now. And our common denominators we said are 20. So we're going to change each of those. What do we multiply a 4 by to turn it into a 20? A 5. So we have to multiply the numerator by 5 as well. 1 times 5 is 5. What do we multiply the 5 by to turn it into 20? 4. So we do what to the 2? Times 4 to get 8. Now we have common denominators. We can add. Remember, when we add or subtract, we combine the counts. 5 plus 8 is 13, and we keep the same name of 20. We're not going to mess around too much with simple fractions. Let's jump up to mixed numbers. A mixed number, like 2 3/8, is just that we have a whole number portion and we have the fraction portion, the pieces that are left over. We might be able to express that as, this is what's called the mixed number. Sometimes express that as what's called an improper fraction. An improper fraction is just we broke the whole thing down into pieces instead of having some of it as whole objects, whole numbers. To change that into an improper fraction, we'd have to break these two whole objects into pieces. How do we know how many pieces are in each of them? Yeah, the denominator tells us. That 8 tells us every whole object is 8 equal pieces. So 2 objects times 8 pieces is 16. We had 3 before, so 3 plus 16 is 19/8. If we had 4 2/5, walk me through it. 4 times 5 is 20. Perfect. 2 plus 20 is 22/5. Perfect. Notice the denominator never changes. The denominator stays the same. We haven't done anything to change its name. We've just manipulated its form. Going the other way, let's say we have 44/7. That's an improper fraction. We can break it down. It's a lot of times easier for us to think of it as whole pieces with, or whole items with pieces left over. Back to the brain chemistry and brain psychology. The human brain, it's been shown that most people's brains can visualize between 7 and 13 things at a time. You try to visualize more than that, things start to fade out of focus. So 44/7 is difficult to visualize. So if we break it down into the number of whole objects we can get, every 7 pieces make a whole object. Well, you could try to divide it out. If you punch that in your calculator, 44 divided by 7, you'll get something like 6.28571429 approximately, which tells us that that is 6 whole pieces with, or 6 whole objects with pieces left over. The key is how many pieces are left over. For me, this works easier if I do it as a long division with remainder. 6 goes into 44. Oops, that's not 6. 7 goes into 44. Come on now. 7 goes into 44 6 times. 6 times 7 is 42. There's 2 left over. That's 2 sevens. So that's 6 and 2 sevens. Okay, so back to our addition. When we add with our mixed numbers, we might have 7 and 1/4 plus 3 and 1/6. We first need to find our common denominator again. What's that going to be for fourths and sixths? 12, good. What's this numerator going to be here on the 12? On top. 3, good. 4 times 3 to make 12, so 1 times 3 to make 3. How about down here? 2, good. 6 times 2 to make 12, 1 times 2 is 2. You can see that fraction is sitting at the end of the number, almost like it's the last digit of the number. And in fact, that's what it really is the last digit of the number. And we're going to treat it exactly like that. Like we would with whole numbers, we're going to start on the right and work our way backwards to the left. So we're going to combine the fractions first. 3/12 and 2/12 is 5/12. 7 and 3, 10. And that's it. Now it doesn't stay that simple. As you guys get to know me, you'll understand that I always make it worse. We might have 18 and 5/6 plus 7 and 3/8. What's our common denominator going to be? 24, perfect. What's this top numerator going to be? 20, good. 6 times 4 to make 24, 5 times 4 to make 20. How about this numerator on bottom? 9, good. 8 times 3 to make 24, 3 times 3 makes 9. We go to add now. Again, we start on the right at the end of the number and work our way back. 20 plus 9 is 29 24ths. What's a little fishy there? It's improper. We can break that down into a whole number and then remaining fraction. If we break that down, what do we get? 1 and 5/24, perfect. Just like with whole numbers, we're going to keep part of it and carry part of it. This is in the fractions place, so we're going to keep the fraction of 5/24, and we'll carry that whole number of 1. 1 and 8 is 9, plus 7 is 16, so 6 carry the 1. 1 and 1 is 2, so 26 and 5/24. Any questions there? Subtraction. What's that? Met your limit? You're okay, all right. Subtraction. I'm not gonna take time for subtraction with just simple fractions. I'm gonna jump into subtraction with the mixed numbers. I might have 8 and 4/5 minus 3 and, let's go 2/3. What's my common denominator gonna be? 15. What's gonna be the numerator on top here? 12, good. How about the numerator on bottom? 10. Just like with whole numbers, I'm going to start at the end at the right and work my way back to the left. And I'm treating this fraction like it's the last digit of my number. 12/15 minus 10/15, 2/15. 8 minus 3, 5. Well, it doesn't stay that simple. Bless you. Bless you again. We might have 9 and 1/4 minus 5 and 5/8. What's our common denominator going to be here? Just the 8. What's the numerator going to be on top here? Careful. 2, there we go. 4 times 2 to make 8, so 1 times 2 is 2. How about on bottom? Yeah, it doesn't change. We kept the 8, so we keep the 5. So now when we go to subtract here, we have 2/8 minus 5/8 can't be done. So just like with whole numbers, we would borrow. That 9 is going to become an 8. Now here's the tricky part. Here's where we have to be careful. What I borrowed was one whole object. How many pieces? How do we know how many pieces are in that object? 8. The denominator tells us how many pieces. So that's what we have to add to our numerator, is 8. 2 plus 8 is 10 eighths. Now we subtract 10 eighths minus 5 eighths. 5 eighths. 8 minus 5, 3. Let's do one more example of that. So 536 and 2/3 minus, what's that? It'll be fine, don't worry. 197 and, oh, let's go 4/5. The big numbers really don't affect it as much as you would think. We still need a common denominator. We have 3 and 5. What's the common denominator going to be? 15. Good. What's this top numerator going to be? 10. 3 times 5, so 2 times 5. What's this denominator on bottom going to be? 12. Good. 5 times 3, so 4 times 3. We go to subtract. We can't do 10 minus 12 fifteenths. So we borrow from the 6. It's going to be 5. What's this going to become here? Perfect. Yeah, the numerator tells us it's 15 pieces we had. 10 plus 15 is 25 fifteenths. Now we subtract. 25 minus 12, 13 fifteenths. Now we move to the next digit, 5 minus 7, got to borrow. So that's a 2, the 3 becomes a 2, the 5 becomes 15. 15 minus 7 is 8. 2 minus 9, borrow again. The 5 will become a 4, and this is a 12. 12 minus 9 is 3. 4 minus 1 is 3. It's not so bad, it's just extra steps. We ready to move on to multiplication? Why not, right? So let's do 1/4 times 2/5. Now remember from the beginning of class here, when we multiply, first of all, we do not need the same name. So for fractions, we do not need a common denominator. Second, we combine the counts, but we also combine the names. So what we were taught for multiplying is just multiply straight across. That's exactly what we'll do here. 1 times 2 is 2. We combine the counts. Combining the names, 4 times 5 is 20. What can we do with that now? We can reduce it. We can simplify it, exactly. Both the 2 and the 20 can be divided by 2. 2 divided by 2 is 1, and 20 divided by 2, 10. So that's 1/10. Some of you might be looking at that thinking, why didn't he just cross cancel? Others might be wondering right now, what's cross canceling? Well, if you look at this, we're going to multiply the numerators. So the numerator of our answer is going to become 1 times 2. We're going to multiply the denominators. So again, in our answer, the denominator is going to become 4 times 5. We look at those and we realize the 4 and the 2 can both be divided by 2. So we could do that before we multiplied. What is 4 divided by 2? 2. What is 2 divided by 2? 1. Now when we multiply, 1 times 1 is 1. 2 times 5 is 10. Basically, we reduced before we multiplied. Now in a problem like this, it's about the same amount of effort either way. But we can run into something like this one. Oh, let's see here. Come up with a good example. Let's do 24 25ths times 35 36. We could very well multiply that out. 24 times 35 is 840. And 25 times 36 is 900. And then we could reduce that. Or we could look at this and ask, what can we cross cancel here? 25 and 35 both divide by what? 5. So 25 divided by 5 is 5. 35 divided by 5 is 7. Anything else? 24 and 36 both divide by, I heard 2, 3, 6. Let's do the 6. What's 24 divided by 6? 4. How about 36 divided by 6? 6. Well, we still see they can still divide by 2. Right? 4 divided by 2 is 2. 6 divided by 2 is 3. We could have divided by 12 in both of those actually, but we don't have to. We can divide by smaller numbers and just keep going if we want to. So now we've got 2 times 4, or 2 times 7 is 14. 5 times 3 is 15. Now, to give you kind of an exercise in reducing, I want to jump back up here to this last one. The 840 over 900. A lot of us were taught that when you reduce a fraction, you have to find that largest number that divides both the numerator and denominator. I'm guessing all of you can look at that and see that they both divide by 60. There's a little sarcasm there. You don't have to divide all at once. I look at it and I see they both end in 0, so they can be divided by 10. So that's, or you just cross off the 0. So that's 84 over 90. Now I'm looking at that and I see that they're both still even. So I can divide by 2. 84 divided by 2 is 42. 90 divided by 2 is 45. Here's where it might get a little more difficult for you. I'm going to show you a trick. Both of those can be divided by 3. How do I know quickly that they can be divided by 3? Well, the trick for telling if a number is divided by 3 or can be divided by 3 is to add its digits together. What's 4 plus 2? 6. Can 6 be divided by 3? Yes, so can 42. What's 4 plus 5? 9. 9 can be divided by 3, so can 45. Any number, no matter how long, if you add its digits together and that result can be divided by 3, the whole number can be divided by 3. Bless you. So 42 divided by 3 is 14. 45 divided by 3 is 15. So we do get to that same answer eventually. Okay. So next, we're going to jump up then to multiplying mixed numbers. Let's do 3 1/4 times 7 3/5. This is my 18th year here. Just throwing that out there. In 17 plus years, I've had one student walk into the room that knows how to multiply mixed numbers. With that said, that doesn't mean you can't multiply them. How do we get around it? Yes, the way we get around it is we turn them into improper fractions. 3 1/4 is going to become what? 13/4. Good. 3 times 4 is 12, plus 1 is 13. The denominator never changes. It stays fourths. 7 3/5, of course, it's going to be fifths. 38. Good. 7 times 5 is 35, plus 3 is 38. Now, this is multiplication. So just like any other multiplication, we can reduce here. We can cross cancel. 4 and 38 can both divide by 2. 4 divided by 2 is 2. 38 divided by 2 is 19. It's that point in the week, I understand. 13 times 19 is, what is that, 247? All right. It is okay to double check with the calculator. I've been wrong before. 2 times 5, I'm pretty sure it's 10. Now we do have an improper fraction that has to be reduced to a mixed number. Again, I'm going to do it out as a division remainder just to make it more visual. 10 does not go into 2, but it does go into 24 twice. 2 times 10 is 20. We subtract to get 4. Bring down the 7. 10 goes into 47. 4 times 10. 40, there's 7 left over, so that is 7/10. So this is 24 and 7/10. Anybody curious as to how we would actually multiply those as mixed numbers? I say a couple of heads nodding. Why not? It won't hurt me. You don't have to write this down. I will never ask you to multiply mixed numbers. I'll ask you to multiply them, but we'll always do it as improper fractions. And you're going to see why in a couple of minutes. So as we're multiplying these, think back to our whole numbers. If I have 82 times 35, not only does the 5 have to multiply the 2, but it also multiplies the 8. Same thing happens here. That 3/5 multiplies the 1/4. 3/5 times 1/4. 3 times 1 is 3. 5 times 4 is 20. But it also has to multiply the 3. 3/5 times 3. How do I multiply a fraction by a whole number? We make the whole number into a fraction by putting a 1 under it. 3 times 3 is 9. 5 times 1 is 5. 9/5 becomes 1 4/5. Now I go to the next digit, the 7. I'm going to multiply the 1/4. So I'm going to make that 7/1 times the 1/4. 7 times 1 is 7. 1 times 4 is 4. 7/4, 1 3/4. Then we just have the 7 times 3. It's 21. There you go. Need a common denominator to combine those. It's going to be 20. So 3/20 stays. 1 4/5 becomes how many 20ths? 5 times 4, so 4 times 4, 16. 1 3/4 will become how many 20ths? 15. Good. 4 times 5, so 3 times 5. Of course, there's no denominator in the 21. 3 and 16 is 19, plus 15 is 34 20ths. That's improper. It's 1 14 20ths. Oh yeah, I know. 14 20ths reduced to 7/10. We carry the 1. 1 1 1 1 is 4, and 2. We do get the same answer. I am going to stick with using the improper fractions. I agree. Yeah. Oh no, I like to make a point that I can hurt you if I want to. Again, the point is, like I showed you with the addition, there's more than one way to do things. There are some people out there, believe it or not, that this makes more sense to them because this is the way you multiply other numbers. Now, I'm going to stick with improper fractions in here, but there are other alternatives. Let's do another example of improper fractions just to get that ingrained in our mind. Let's say we've got 5 1/4 times, let's do 7 2/3. Tell me what to do. Perfect. 5 times 4 is 20, plus 1 is 21 over 4. What's next? Perfect. 7 times 3 is 21, plus 2 is 23 over 3. So yes, all we're doing is taking the whole number times the denominator. 5 times 4 is 20. Adding that to the numerator to get our new numerator. 7 times 3 is 21, plus 2 is 23, get 23/3. Now at this point, these are fractions. We can cross cancel. Did you get it figured out? You got her? Okay. Oh, sorry. So now we can cross cancel. What can we cross cancel here? 21 and 3. What's this going to become? 21 divided by 3 is 7. What's this going to become? 1. 3 divided by 3 is 1. Now what? 7 times 23 is what, 161? 4 times 1? 4. So to get that reduced to our 40 and 1/4, we're going to divide it out. 4 does not go into 1, but 4 goes into 16 4 times. 4 times 4, 16. We subtract the 0 left. Bring down the 1. Does 4 go into the 1? No. We have to be very careful here. I'll see a lot of mistakes on this. It didn't go in there, so we do have to put a 0 above the 1. Now there is 1 left over, 1/40. So it's 40 and 1/4. Any questions? Now you can use your calculators on this. I'm going to show you a little trick here for dividing this out. That 161 divided by 4. If you're going to try to use your calculator, here's what you would do. Obviously, if you divide it out, it's going to give you a decimal, 40.25. Notice that 40, the whole number portion, is the whole number portion of our mixed number. How do I get the fraction? Well, I'm going to subtract off that whole number portion of 40. Leaves me with just the decimal. That decimal portion is the fraction in decimal form. How do we turn it back into a fraction form? We're going to multiply by our numerator, our denominator of 4. That is 1/4. Okay. Division. I've mentioned it a little bit before. Division is the one operation that is twisted and abbreviated to the point where it's not recognizable. If this were a more basic course, I'd show you division, the long division process with whole numbers. The actual long division process is just that, long, very long. I'm going to take up most of a sheet of paper. But if you see that process, what we were taught for that long division makes more sense. You see where those steps come from. With fractions, it's no different. We multiplied fractions just going straight across. Numerator times numerator, denominator times denominator. I told you earlier that multiplication and division follow the same rules. So, can I divide straight across and do 12 divided by 4 is 3? 25 divided by 5 is 5? Is that the right answer? Actually, it is. Does that work every time? Yeah, it does. This problem, sometimes they're not divisible. The reason we don't do it that way is we run into problems like this. 3/4 divided by 2/3. If I tried to divide straight across, 3 divided by 2 is like 1.5. 4 divided by 3 is 1.3333. What's that? Okay. Yeah, how were we taught? There's a couple of methods that most of us have been taught. Some of us were taught like the zigzag method or cross multiply. We do that. 3 times 3 is 9. 4 times 2 is 8. Most of us were taught to do what? Flip it. It's called the reciprocal. So the 2/3 becomes 3/2. And then we are multiplying. The key is an operation always operates on the number that comes after it. So that dividing is operating on the 2/3. So it's the 2/3 that has to get flipped over, or we have to take the reciprocal of. So now we just multiply. 3 times 3 is 9. 4 times 2, 8. 9/8 or 1 1/8. We're going to take a little trip into math history here again for just a second. That process actually comes from what I did up here. And I'm going to show you how quickly. You don't need to write this down if you don't want to. At one point, before we started doing that multiplying by the reciprocal, well, before they started doing it, it was way before my time. But the way they would have done this is they'd have looked at it and said, okay, these don't divide out evenly, so we're going to look at the number we're dividing by, the 2/3, and we're going to multiply the numerator and the denominator. So 2 times 3 gives us 6. We are going to use that 6 to rename the first fraction. We're going to take 3/4. We're going to multiply both the numerator and denominator by 6. Bless you. 3 times 6 is 18. 4 times 6, 24. Now, 18/24 and 3/4 are the same value. They just look different. Now we're going to divide by the 2/3. 18 divided by 2, 9. 24 divided by 3, 8. 9/8, or 1 1/8. So how did we get from this to multiplying by reciprocal? It's not as big of a leap as you might think. If we set this all up together like this, at one point somebody looked at this and realized, hey, if we stretch things a little bit, stretch our process a little bit, if we look at this part here, 6 divided by 2 is 3. 6 divided by 3 is 2. If we did that division first, what we always get here is just this fraction flipped over. So they gave that the name of reciprocal. And then what's left is to multiply. So since that always turned out to be like that, they just shortened the process and said, when we divide, we're going to take the reciprocal and multiply. So let's take a look at mixed numbers with our division. 5 1/2 divided by 2 3/4. Since we are going to turn this into multiplication, we're going to take a reciprocal and multiply. It makes sense that we're going to do the same thing we did with multiplication, and that is make them into improper fractions. 5 1/2 is going to become 11 over 2. Good. 5 times 2 is 10, plus 1 is 11. So 11 over 2. 2 3/4 will become 11 over 4. 2 times 4 is 8, plus 3 is 11 over 4. This is still division at this point. Which one do we flip? The 11 over 4 becomes 4 11ths. Remember, the operation always operates on the number that comes after it. So the 11 over 2 stays the same. This is going to become times 4 over 11. Now that this is multiplication, we can cross cancel. We can cross cancel a lot here. The 11s divide out completely. 11 divided by 11 is 1 in both spots. 2 and 4 divide by 2. 2 divided by 2 is 1. 4 divided by 2 is 2. We got 1 times 2 is 2. 1 times 1 is 1. So 2 over 1, or just 2. Let's do one more example of that. Let's do 5 3/8 divided by 1 and, let's 1 1/4. Tell me what to do. Make them improper, okay? 5 3/8 will be 43 over 8. Good. 1 1/4, 5/4. Now, don't ever make the mistake of trying to cross cancel at this point. It is still division. Now, there's nothing to cancel here anyway, but just a warning. What's next? Reciprocal of the 4/5, or 5/4 becomes 4/5. That's multiply now. Now we could cross cancel. Both of those divide by 4. We get 1 and 2. Good. And then 43 times 1 is 43. 2 times 5 is 10. So I'll let you guys reduce that down to 4 3/10 on your own. Any questions? Now, I had to show you how to do those by hand because on that first test, like I said, you'll have to be able to show the steps. There is a magic little button on most of your calculators. It looks like that, ABC. I don't have one on my on-screen calculator, so I can't show it to you. But that neat little button there will take a problem like this, 5 3/8 divided by 1/4. Or divided by 1 1/4, I should say. And it'll do that pretty much all for you. To enter 5 3/8, if you have that key, you just hit 5, you do the whole number, you press that key, you do the numerator, which is 3, press that key, you do the denominator. That's how you would enter 5 3/8. Divide, 1 for our whole number, press the key, 1 for our numerator, press the key, 4 for our denominator, hit equals, and it better spit out. It'll probably look something like this. 4 3/10 is what that's displaying. Some of your calculators actually have the slash for the fraction. If you have something that's got a little bit different button than the ABC key, let me know and I'd be happy to go over it with you individually. Okay, we're running up on our time here, so a couple of things I want to show you quick before we totally run out of time. Just a couple of things with decimals. We had our place values earlier. And just to shorten it up a little bit, I'm going to write in the place values numerically. Ones, tens, hundreds, 1,000s, 10,000s, 100,000s, and so on. I may have mentioned it before, but math is all about patterns. If you see the patterns, everything falls into place. Here, the pattern is, if I move one place value to the right, the value is divided by 10. Going from 10,000 to 1,000, I would divide by 10. 1,000 divided by 10 is 100. 100 divided by 10 is 10. 10 divided by 10 is 1. So if I keep going on the other side of the decimal point, 1 divided by 10 is 1/10. 1/10 divided by 10 is 1/100th. 1/100th divided by 10 is 1/1000th. 1/10,000th. 100,000th. Oops, got my decimal in the wrong place. And so on. You might be looking at these place values and thinking they look suspiciously like fractions. That's what they are. Decimals are nothing more than a short way, abbreviated way of writing some fractions with common denominators, powers of 10. 0.64 as a decimal stands for, how would we pronounce that officially? 64 hundredths. We read the number 64 and then the place value of its last digit. Well, it really is the fraction 64 over 100. And of course, that can be reduced. You divide both of those by 4 to give us 16/25. If I have 7.0375, that is 7. The part in front of the decimal point is a whole number. It's the part after the decimal point that is a fraction. That's 375 over what? 10,000. Good. Tenths, hundredths, thousandths, 10 thousandths. A sneaky little way to double check yourself. 1, 2, 3, 4 decimal places. 1, 2, 3, 4 zeros in my denominator. And of course, that fraction can be reduced, but I'm going to trust that you guys can do that. If I have, let's say I have 3.81 plus 14.7. Come on. Is that going to work? No, what's wrong? Have to line up the decimal points. Somewhere along the line, we were told when you add or subtract decimals, you must line up the decimal point. Why? Yes. Everything, you can only combine things with addition and subtraction that have the same name. Lining up the decimal points, make sure that we combine the tenths with the tenths, the hundredths with the hundredths, the ones with the ones. We're making sure we have the same name. Now we'll go ahead and add 1 and 0 is 0. Or 1 and 0 is 1, thank you. My little hamster's already in the campground for Labor Day weekend. 8 and 7 make 15, so 5 carry 1. Notice the decimal point does not affect our carrying. But before we do the next column, we do need to bring the decimal point straight down. 1, 3, and 4 makes 8, and then the 1. The reason we brought the decimal point straight down is we have hundredths plus hundredths. It has to stay hundredths. Bringing the decimal point straight down is keeping the same name. And of course, subtraction is very similar to that. Let's say I have something like 0.21 times 0.3. Do I have to line up the decimal point when I multiply? No, because when we multiply or divide, we do not need the same name. We're going to go ahead and multiply 21 times 3 is 63. Where does my decimal point go? We have to put a 0 there. Why? That's a good question. Why? Okay. Yep, I'm here. We were taught you have to count 1, 2, 3 total decimal places in the problem. 1, 2, 3 total decimal places in the answer. So then again, why? Well, you got the right idea. This is 21 hundredths, so this is 3 tenths. 21 times 3 is 63, but when we multiply or divide, we also combine the names. Hundredths times tenths is thousandths. So counting those decimal places and putting that many decimal places in the answer is just combining the names. So as you can see, my big point here is that all of those different processes we do with different forms of numbers are not special new rules. They're all the same rule, they just look a little different because of the form of the number. Okay, we did not get through quite everything. We still have order of operations to do. So if you're looking at the list of the assignments, where the only page we didn't get to was page 23. If you want to attempt that and work on it, you can. Like I said, I will not collect and grade homework. So what you should be working on to practice are pages 7 and 8, which is the 1 through 59, the odds. Page 18 through 21, the 1 through 97, the odds. I do the odds just to make it a little bit less work for you. And page 29 through 32, that is 1 through 91, the odds. Now there's a lot of problems there. 1 through 91, the odds. There's a lot of problems there. I'm not necessarily expecting that you're going to do all of those. Remember, I had mentioned if you do the first couple and they're really easy, skip ahead to some of the more difficult ones. I'm not here to give you a bunch of busy work on stuff you already know. If you already know it, skip ahead. Make sure you do the more difficult ones. Make sure if there are word problems, you try the word problems. But as long as you are comfortable with it and know you're ready for the test, That's what the homework is for. So don't stress out if you don't do every problem. Okay, it is that time. So you guys have a great weekend, and we'll see you next week.